Example number 3 says a wooden pallet carrying a load of 600 kilograms rests on a wooden floor. Mu s, which means the coefficient of static friction, is 0.28, and mu k, the coefficient of kinetic friction, is 0.17. A forklift driver decides to push it without lifting it. What force must be applied to just get the pallet moving? Letter B says, after a bit of time, the pallet begins to slide. How fast is the pallet moving after sliding under the same force you calculated in part A for half a second? And then part C says, if the forklift driver stops pushing, how far does the pallet slide before coming to a stop? So let's concentrate on part A first. Now we're given a mass of 600 kilograms. And then we're given the coefficient of static friction is 0.28 and the coefficient of kinetic friction is 0.17. Notice how the coefficient of static friction is larger than the coefficient of kinetic friction because we know that it is harder, right? The friction force is larger when something is not moving. And then as soon as it gets moving, then the friction force drops down. So let's draw a free body diagram of what's happening here. So I have my pallet. The applied force is to the right, friction force to the left, normal force up, and then the force of gravity down. And we can just assume that the applied force is just directly horizontal. They're not giving us any angles or anything like that. Okay, so for part A, it says the forklift driver decides to push it without lifting it. What force must be applied to just get the pallet moving? When they say this right here, they're saying just as it starts moving. So they're basically saying that we want to overcome that force of static friction. So that means that the applied force will be equal to the maximum static friction force because we're just starting to move. Okay, so the applied force, so this is part A, applied force will be equal to the force of static friction maximum. Okay, so we know that the force of friction is equal to mu times the normal force. We also know that this is mu static. And again, this is the maximum force of static friction. So our mu static was equal to that 0.28. And then here in the free body diagram, we can see that the normal force is equal to the force of gravity because those are the only two forces acting in the vertical y direction, and we're not accelerating in the vertical y direction. So that means that my forces are balanced in the y direction. So I get applied force is equal to mu s times the force of gravity, which is equal to mu s times mass times acceleration of gravity. So plugging our numbers in, we get mu s, static friction coefficient, is 0.28. And then the mass of that pallet was 600 kilograms. And then the acceleration of gravity is 9.8 meters per second squared. So we get 0.28 times 600 times 9.8 is 1,646.4 newtons, right? So then for part B, it says, after a bit of time, the pallet begins to slide. How fast is the pallet moving after sliding under the same force you calculated in part A for half a second? So for part B, we want to know how fast. So that's our final velocity, right? After a time of 0.5 seconds, half a second. Now our initial velocity here is going to be 0 because that pallet was initially at rest. So what we need to do here is first we need to find acceleration in order to be able to use our first basic equation in order to find that final velocity. So using Newton's second law, net force is equal to mass times acceleration. The net force here, same free body diagram, will be equal to that force applied minus the force of friction equals mass times acceleration. Now here we are moving for this part B. So how fast is the pallet moving after sliding under the same force? So we are moving, which means our force of friction is equal to the kinetic force of friction. So we end up getting applied force minus mu k times the normal force equals mass times acceleration. So here again, we know that the normal force is equal to the force of gravity, which is mass times acceleration of gravity. So we get force applied minus mu k times mg equals ma, and now we can start plugging in our numbers. You can also divide both sides by m because we are solving for acceleration. So acceleration, and I'm going to do that actually. So acceleration, we get applied force, which we just found was 1,646.4 newtons, minus mu kinetic, which was 0.17, times the mass of the crate, 600 kilograms, times the acceleration of gravity, 9.8 meters per second squared, all divided by the mass of the crate, 600 kilograms. So we end up getting 1.078 meters per second squared. And then we're not done yet because that's the acceleration, but we want to know the final velocity. So I know the first basic equation says final velocity equals initial velocity plus acceleration times time. So final velocity will be 0 plus 1.078 meters per second squared times time, which was 0.5 seconds. And that is equal to a final velocity of 0.539 meters per second. So that's part B. And then part C, it says, if the forklift stops pushing, how far does the pallet slide before coming to a stop? So now the forklift is going to stop pushing, which means that our applied force is gone. So for part C, we have no more applied force, but our friction force is the one that is going to be making that pallet slide to a stop. So that means the net force is equal to mass times acceleration. Again, net force here is the friction force. And I'm gonna still call to the right positive because I know that we're sliding to a stop, which means if I have a positive velocity, I'll get a negative acceleration. So that means a negative friction force equals mass times acceleration. Solving for acceleration here, we get negative mu k, still kinetic because we are still moving, times the normal force, which of course is mass times acceleration of gravity, divided by mass. Notice how mass cancels out here. And we get an acceleration of negative mu k, which was 0.17, times the acceleration of gravity, 9.8 meters per second squared, which is equal to 1.67, negative 1.67 meters per second squared for our acceleration. And then if we want to know how far it slides, it says for part C, how far does the pallet slide before coming to a stop? We know that the initial velocity is this final velocity right here. So that will be our initial velocity, the initial for part C. We know the acceleration, and we know that the final velocity is 0. So we can use that v final squared equals v initial squared plus 2 times acceleration times delta x, because that is what we are solving for here. So final velocity is 0 equals initial velocity, which is at 0.539 meters per second. We're squaring that, plus 2 times a negative 1.67, I'm running out of room, times delta x. So this 1.67 times 2, so we get 3.34 equals, 3.34x, delta x. I just added that to both sides. We get 0.539 squared, 0.29, and then dividing both sides by 3.34, and we get our delta x is equal to 0.087 meters. So about 8.7 centimeters is our answer for part C.